Problem number 3. If omega is a cube root of unity not equal to 1, which means omega is a non-real cube root of unity, then the minimum value of a plus b omega plus c omega squared, where a, b, c are integers not all equal. Okay, we need to find the minimum value of modulus of a plus b omega plus c omega squared. Let us take y is equal to modulus of a plus b omega plus c omega squared. We need to find the minimum value of y. Y is minimum when y squared is minimum. So y squared is equal to modulus of a plus b omega plus c omega squared. We can use the relation mod z squared is equal to z into z conjugate. So this becomes a plus b omega plus c omega squared times a plus b omega plus c omega squared, the whole conjugate. So that is equal to a plus b omega plus c omega squared times a conjugate is a, since a is an integer, and b conjugate is also b, so this becomes b omega conjugate plus c omega squared conjugate. Okay, now what is omega conjugate? We have omega into omega conjugate will be equal to modulus of omega squared, and modulus of omega is 1, since omega is a cube root of unity. So we have omega into omega conjugate will be equal to 1, so that omega conjugate will be equal to 1 by omega, and that is equal to multiplying by omega squared, we get omega squared by omega cube. Omega cube is 1, so that is equal to omega squared. So omega conjugate is omega squared. And what is omega squared conjugate? Omega squared conjugate will be equal to, this can be written as omega conjugate squared, and omega conjugate is nothing but omega squared. So omega squared the whole squared, that is equal to omega raised to 4, and that is equal to omega, since omega cube is 1. Now continuing this, a plus b omega plus c omega squared times a plus b omega conjugate is omega squared plus c omega squared conjugate is omega. Now expanding this, we get a squared plus ab omega squared plus ac omega plus ab omega plus b squared omega cube plus bc omega squared plus ac omega squared plus bc omega raised to 4 plus c squared omega cube. So that is equal to a squared plus ab omega squared plus ac omega plus ab omega plus b squared, omega cube is 1, plus bc omega squared plus ac omega squared plus bc omega, since omega raised to 4 is omega, plus omega cube is 1, so this becomes c squared. Okay, that is equal to a squared plus b squared plus c squared. Now ab omega square is there and ab omega is there. If you take ab outside, remaining will be omega plus omega squared. Again ac omega and ac omega square is there, so if we take ac outside, then it will be omega plus omega squared plus bc omega squared, and bc omega is there, so if we take bc, remaining will be omega plus omega square. Now what is omega plus omega square? 1 plus omega square is 0, so that omega plus omega squared becomes minus 1. So this becomes a squared plus b squared plus c squared minus ab minus ac minus bc. Multiplying and dividing by 2, we can write this as 1 by 2 into 2a squared plus 2b squared plus 2c squared minus 2ab minus 2ac minus 2bc. Splitting this 2a squared into a squared plus a squared, 2b squared into b squared plus b squared, and 2c squared into c squared plus c squared, and rearranging, we will get 1 by 2 into a squared minus 2ab plus b squared plus a squared minus 2ac plus c squared plus b squared minus 2bc plus c squared. So that is equal to half into a minus b the whole squared plus a minus c the whole squared a minus b the whole squared plus a minus c the whole squared plus b minus c the whole squared. Now given that a and abc are integers and not a, b, c all are not equal, and also we can see that a minus b the whole squared plus a minus c the whole squared plus b minus c the whole squared will be an integer, since a, b, c are integers and it is a positive integer. If it is equal to 0, then what happens is a equals b equals c, which is not true. Again, if it is equal to 1, then what happens is two of them should be 0. If two of them should be 0, for example, if this is 0 and this one is 0, first and second is 0, then a is equal to b and a is equal to c, which makes a equal to b equal to c. So that is not possible. So the next integer value will be equal to 2. So this can be 2 when two of them are equal to 1 and the third one is 0, and which happens if two integers are equal and the third integer will be exactly differ by 1. At that time the sum will be equal to 2 and that will be the minimum value. So the minimum value of y squared, so minimum value of y squared will be equal to 1 by 2 into 2, that is equal to 1. So that we can conclude that the minimum value of y is also 1. So the correct option is option C.